In this lesson, you'll be able to recognize 6 types of quadrilaterals, and you'll be able to find the area of those quadrilaterals as well. Alright, so first we'll talk about the different types of quadrilaterals. First is a trapezoid, and it has exactly one pair of parallel sides. So if you look here, this is an example of a trapezoid. And it looks like an isosceles trapezoid because these two sides look congruent, so it looks like an isosceles trapezoid. But trapezoids, they have two sides that are parallel and two sides that are not to one another. Yeah. Then you have a parallelogram, and with a parallelogram, you have two sets of parallel sides. So this is a parallelogram. Number 2 is a parallelogram. Oh my gosh, that's not how you spell parallelogram. Number 4 has two sets of parallel sides, parallelogram. And number 5, it's a parallelogram. Okay, because this is parallel to this, and this one's parallel to this one. All right, a rectangle has 4 congruent angles. Okay, so number 2 is a rectangle. All right, number 4 is a rectangle. Okay, and then in all 4 of those angles are 90 degrees. Because remember, there's 360 degrees in a triangle. 360 degrees in a quadrilateral. And if all 4 of those angles are congruent, 360 divided by 4 is 90. A rhombus has 4 congruent sides. So number 4 is a rhombus, and number 5 is a rhombus. And a square has 4 congruent sides and congruent angles, so this is a square. So if you look at a square, it's a rectangle, it's a rhombus, it's a parallelogram. Right? A rectangle is a parallelogram, and a rhombus is a parallelogram. This is just a plain old quadrilateral. It doesn't have any of those characteristics. It's a regular old quadrilateral, nothing fancy. There's another one I want to talk about, and it's a kite. And it has 2 pair of congruent consecutive sides. And it looks like a kite that you've probably grown up knowing about. So these 2 sides are congruent, and these 2 sides are congruent. Now, if all 4 sides are congruent, it's still considered a kite. So guess what? A square is a kite, and a rhombus is a kite. All right. So a square is a kite, a rhombus, a rectangle, a parallelogram. If something's a parallelogram and a kite, then it has to be a rhombus. All right, so those are your 6 basic types of quadrilaterals. And what we're going to do with them is we're going to find their area. So the first one we're going to do is the area of a parallelogram. And this works for any parallelogram. So it could be a square, a rhombus, a rectangle, and any other type of parallelogram. The area of a parallelogram is base times the height. And base and height are always perpendicular to one another. So the base is one of the sides of the of the parallelogram, and then the height is the distance between that side and the side opposite it, and you got to make sure it's perpendicular. So let's look at number 1. Again, area equals base times height. So the base of this parallelogram is 8 and the 10. So we're going to add those together, and that's going to be 18. And the height is 16. And we multiply this together, we get 288, and it's feet squared. So area is always squared. All right, let's look at number 2. We have that it's 24, the base is 24, but they didn't label the height. But what we're going to do is we're given that this angle is 60 degrees. So in a parallelogram, the opposite angle is also going to be the same, which is 60 degrees. So we have a right triangle here. All right, we know that this is 60 degrees. We know that this is 24 because they marked all the sides congruent. And we want to find this, the height. And we're looking at, let me see if I can draw this right. We're looking at this triangle right here. Okay, this is the triangle we're talking about. All right. So I just kind of pulled this triangle out. So we're going to use trig to find that missing side. So we want to know this side. The hypotenuse is labeled. The other side that's labeled is opposite. Okay, so this is going to be sine then. And remember, sine is opposite over hypotenuse. Put that over 1. H equals 24 times sine of 60. And we put that in the calculator and we get that the height is 20.8. All right? So this right here is going to be 20.8, the height. So area equals base times height. The base is 24. The height is 20.8. So the area of this parallelogram is 498.8 inches squared. So again, sometimes you're going to have to, on these parallelograms, you're going to have to use some trig work to figure out the missing height. Alright, so let's look at number 3. It's a square. A square is a parallelogram. This is going to be 90 degrees. So the base is 1.6, and because that side is perpendicular, it is also the height. So the area is just going to be 1.6 times 1.6. And in fact, some people teach that the area of a square is just the side square. In fact, most people do. So we're going to do 1.6 times 1.6, or 1.6, and we get that side is 200, or sorry, that area is 2 56/100 centimeters squared. All right, let's look at number 4. So number 4, again, they give us the base, but they don't give us the height. We're going to use a right triangle. So again, we're trying to find this height. Here's the angle they give us. They label the hypotenuse. That's opposite. So it's going to be sine of 45, opposite over hypotenuse. I'm going to put this over 1. So h equals 22 times the sine of 45. And when I multiply those, I get 18.7. Alright, so the area equals 26, because that's the size that's perpendicular to the height, times 18.7, which is 486.2, and it's inches squared. So if you're missing the height on a parallelogram, lots of times you use trig to find that missing height. And the area of a parallelogram is base times height. Trapezoids. So again, a trapezoid is one pair of parallel sides called the bases. Okay, so if you look here, this is a base 1, and this is base 2. The height is the perpendicular distance between the two bases. Again, it has to be perpendicular, and it should be perpendicular to both. And the area of a trapezoid then is 1/2 that height times the two bases being added. So area equals 1/2 the height times the two bases being added. So 1/2 times the height of 16 and then 18 plus 32. One half of 16 is 8. 32 plus 18 is 50. And then when I multiply those, I get it's 400. And then we're talking about feet, so feet squared. Make sure when you do your areas and you give you a dimension that then you write the dimension afterwards squared. example 2, area is going to be 1/2 the height, which is 28, times my 2 bases being added. Remember, the bases are the parallel sides. 1/2 of 28 is 14. Those two added together are 36. And I get 504 yards squared. So area of a trapezoid is the height, and half of the height is 1/2 the height times the 2 bases being added. Finally, we're going to talk about the areas of rhombi and kites. Rhombi is the plural of rhombuses. Rhombuses, that doesn't sound right. So rhombus is a parallelogram with 4 sides congruent. A kite is a parallelogram with 2 sets of consecutive sides congruent. A rhombus is a type of kite. The area of those is 1/2 your 2 diagonals multiplied together. And a diagonal goes from one angle to another through the parallelogram, or the kite, or the rhombus. All right. So here, this is a diagonal here. All right. So if I multiply those 2 diagonals and divide that by 2, then I get the area of the kite or the rhombus. So let's look at number 1. So area equals 1/2 diagonal 1 times diagonal 2. So 1/2, let's see, this one is 56 plus 26. And the other one is 20 plus 20. All right. So that's 1/2, 82 times 40, which is 1,640 inches squared. All right, let's look at number 2. You see these congruent marks. So this is also 10 and this is also 20. So it's going to be 1/2 the 20 plus the 20. And the 10 plus the 10. So it's 1/2 40 plus, times 20. Make sure I write that clearer. Which is 400. Right? And then finally, this kite here. We have 24 and 24. And then 18 plus 10. So 1/2 48 plus 28, which is 672 feet squared. Notice the diagonals of a kite and a rhombus are always perpendicular to one another. So that's an interesting fact. And number 2, I know, is a rhombus because the diagonals bisect each other. They split each other into 2 equal pieces. So number 2 has to be a rhombus. For a kite, only one set of diagonals is split into 2. So if you notice number 3, 24 and 24, and number 1, 20 and 20. Real quick, I just want to kind of talk about some of your examples. When you see your problem, it'll look like this. So here's a kite. And they'll go from here to here is 4, and we'll say yards. And like from here to here is 10 yards. So they're saying the 2 diagonals are that. So that would just be 1/2, one diagonal, which is 4, one diagonal is 10, which would be 20 yards squared. Okay, so sometimes that's how the diagonals are labeled. So your 6 quadrilaterals that you should know about are parallelograms, rectangles, rhombuses, squares, and kites, and you should be able to find the area of those objects. So now you're going to do 1 through 3, 1 through 6, and then your writing prompt.